In this lesson, we'll take a look at how electrostatic induction and conduction work, as well as some of the rules for repulsion and attraction among charged and neutral objects. In the setup here, you have one neutral object that has an equal number of plus and minus charges represented there with the plus and minus symbols. And over here on the left, we have an object with an excess of negative charges, so more electrons than protons, and the result is a negatively charged object on the left. When the negatively charged object is brought near the neutral objects, the electrons in the neutral object respond by moving to the far side of the object. Notice that there are still, in this example, 6 negative charges and 6 positive charges, but the negatives have moved away to the right because they can. Electrons are freer to move throughout an object. The protons are essentially fixed in place. So now you have a situation where the near side of this object is still negatively charged, but this side of the neutral object has a partial positive charge. The result is an opposite charge attraction event. This neutral object will attract to this charged object. So at this point, induction has caused a separation in charge that leads to an attraction between the two objects. Neutral and charged objects attract one another because of the separation of charges. What happens, however, if there's enough attraction that the two actually make contact? At that point, we have a conduction event occurring between the two objects. In an event where conduction is occurring, transfers of charges occur across the surface. In this case, the electrons from the negatively charged object will move to the neutrally charged object in an attempt to balance out the charges. They'll go from the higher density source to the lower density source. And the result is this object over here becomes negatively charged as well. This object remains negative, although not quite as negative as it was before, and this one now becomes negative. The two negative charges will repel one another. So what you would observe here is the two objects attracting one another initially because of induction, and then after a brief moment of contact, repelling one another because of conduction. So now to summarize, if the two charges are identical, plus plus or minus minus, you'll see the two repel each other. If the objects are oppositely charged, plus minus or minus plus, you'll see them attract. If you have two neutral objects near each other, you'll see nothing happen. There'll be no attraction or repulsion. And if you have a neutral object next to any charged object, plus or minus, you'll see an attraction. So when you're making observations, if you see a repulsion event, you know for sure they're similarly charged. If you see no event, you know that they're both neutral. And if you see an attraction, you have to make a decision between opposite charged and neutral and charged, often based on an additional piece of information.